So, the first section of the textbook, I mean, this also corresponds to the Khan Academy, and I thought it could maybe just be heard from my voice. But the textbook talks about, it begins by talking about right-angled trigonometry, and different resources will probably start different places. But I think the thinking here is for you to just get an understanding of sine, cosine, and tangent. And I'm not going to worry too much about the inverses in this video. But I have sine, I have cosine, and I have tangent, which are my three primary trigonometric ratios, we call them. And so there's actually a mnemonic that we use to remember these, and it goes like this. It's called so-ka-toa. So-ka-toa. And you notice that so, ka, and toa all consist of three letters. If we were in class together, we would do our chant, slamming the table like this. So, ka, toa. So, ka, toa. So, ka, toa. Because it's a great way to memorize that sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So you may not know, you might say, Mr. Tannen, what the heck are you talking about? Well, when we're learning about trigonometry, we call it right. Let me try redrawing that so it's a little bit better. We call it it all has to do, a lot of it, from right triangles. So if I have a right triangle here, I know it's not perfect, but it's not horrible either, I don't think. Oh no, maybe it is horrible. Let me just redraw this by hand. So if I just pick an angle, we're not going to talk about this one. We're not going to talk about the right angle, because the right angle, the ratio is going to be hard for us to talk about adjacent versus opposite. But let's say I'm talking about this angle here. I'm going to call it theta, which is denoted with this Greek symbol theta, which is sort of a circle with a little line through it here. That's different from this. That was just saying we're not going to talk about this one here. But we are going to talk about this angle theta. So if I think about theta, well, the triangle always has a hypotenuse if it's a right triangle. So the hypotenuse is always this longest side. But if we now think, looking at our angle theta, which is right here, if we think about what is opposite to it, the opposite side is the one sort of on the other side from the angle. And then the adjacent to theta will be the one that's right next to it. So what this means is, if we have a triangle, let's say that the adjacent is 3, the opposite is 4 units, and the hypotenuse is 5, which is one of our Pythagorean triples, right? 3 squared plus 4 squared equals 5 squared. We could now calculate the sine, cosine, and the tangent. Let's walk through how. We said so is sine is opposite over hypotenuse. So this would be opposite over hypotenuse, which equals 4/5. 4 over 5 or 4/5. We said cosine in the ka, so ka-toa. Ka is adjacent over hypotenuse. So you'll notice sine and cosine are both over the hypotenuse. Well, the adjacent side we said was 3, so we'll divide 3 by the hypotenuse of 5. So the cosine of theta, which we could write like this, cos of theta equals 3/5. Let me do the same for my sine above here. sine, and you notice we just write the first three letters of theta equals 4/5 in this case. And then the tangent is my last one that I did in green here. We said that's TOA, which is opposite over adjacent. So that's the one that does not involve the hypotenuse. It's more the ratio of the opposite over the adjacent side, which in this case is 4/3. And the way we would write that is the tan of theta equals 4/3. So that's sort of the basic of sine, cosine, and tangent. The textbook gets into what they call cosecant, secant, and cotangent, which are just the reciprocals of each of these. So cosecant is the reciprocal. So they write it like this: cosecant, secant, and cotangent. So the cosecant of theta would just be 5/3. The reciprocal, the secant of theta would be 5/3. Or did I say 5? I meant 5/4 on the first one. This one's 5/3. And cotangent would be 3/4. So that's a basic intro to sine, cosine, and tangent. And if they give you a problem in that section with a missing side, you could always just use the Pythagorean theorem to find the third side, right? A squared plus b squared equals c squared.